Welcome back to this explainer. Okay, today we're putting all the theory aside and we are getting our hands dirty. We're going to do a highly focused, step-by-step, practical walkthrough of a single, highly successful web application exploit. And we're going to do it all using Burp Suite. There's no fluff here, no distractions, just pure over-the-shoulder penetration testing. As we go through this, we'll be looking at real screenshots of the target website and our testing environment. And I'm going to explain literally every single command we execute and exactly why we're using it. Let's get into it. Okay, let's dive into this. How do you actually use a tool like Burp Suite, which, is often called the Swiss Army knife of web security testing, to execute a successful automated attack completely from scratch? For this, I want you to plunge straight into the mindset of a penetration tester who is just sitting down, firing up their terminal, and scouting out their very first target. Your goal here isn't just to browse the web. Your goal is to find the hidden cracks in its foundation.
First things first, we need a target. For our purposes, we're using a purpose-built, intentionally vulnerable web application called OSP Mutilidae 2. We've navigated our built-in browser over to the target's IP address just to begin our initial reconnaissance. Right now, we're simply establishing our initial connection to make absolutely sure the application is up and running. But as you'll see, we aren't just browsing blindly here. To actually pull off this exploit, we're relying on a totally core concept in pen testing, the intercepting proxy. Burp Suite is configured to act as a man in the middle. It literally sits perfectly between your web browser and the application's web server. That means every single piece of HTTP traffic, every request, every response flows directly through Burp Suite before it goes anywhere else. This is a real game changer because it allows us to see the hidden back-end traffic operating behind that seemingly secure front-end user interface.
So here is the chronological blueprint to set up our wiretap. Step 1, we navigate to the target's login screen in our browser. Step 2, instead of actually logging in, we immediately switch over to our Burp Suite interface and open the proxy tab, specifically looking at the HTTP history subtab. And step 3, we look through that history to capture the initial GET request that our browser made just by loading up that login page.
Now, what's really interesting about this raw data we uncover is what happens when we observe the server's response. When we requested the login page, the server responded with a very vital assignment, a set cookie header. Specifically, it handed us a PHP SSEDI value. This string of characters is our unique session identifier. By capturing this right off the bat, we can ensure we have a totally fresh, unauthenticated session to begin our testing, straight from the server itself.
We have our target request, right? But simply observing isn't attacking, so we execute a pivotal command. We right-click right there in the raw request pane and select Send to Intruder. Or, you can just use the keyboard shortcut Control+I. Why do we do this? Well, we're transitioning from a passive state of simply watching the traffic flow by to an active state. We're taking this exact legitimate request and moving it into a tool where we can actually configure an automated brute force attack. To understand why the Intruder tool is absolutely essential for this, let's consider this defining principle. Burp's Intruder tool can automate fuzzing by sending a large number of varied payloads to endpoints, enabling systematic testing for security issues. Fuzzing is, essentially, the technique of throwing everything, including the kitchen sink, at a door just to see what breaks the hinges. We need Intruder to systematically fire off rapid-fire variations of our inputs to hunt down hidden authentication flaws. Because doing all of that manually? No way. That would take forever. Let's take a quick guided tour through this Intruder interface. First up, we navigate to the Positions tab. Now, Burp automatically highlights all the parameters it thinks we might want to attack. We actually clear those out, highlight only our target parameter, which in this case means the login inputs, and we click the Add button to define our specific payload positions. Then, at the very top, we select the Sniper attack type. The Sniper attack is incredibly precise. It methodically takes one payload list and injects it into our specific target position one by one.
Okay, now for the final blueprint configurations, over on the Payloads tab. We select a simple list as our payload type. Then we populate our list with targeted payload values. For this particular exploit, we're feeding it common, potentially vulnerable inputs, like the username admin. We explicitly uncheck the payload encoding box at the bottom. This is super important because we want our payloads sent exactly as they are without URL encoding messing up our syntax. Finally, we move our cursor to the top right and click the Start Attack button to launch the heist.
So we've hit Start,
Burp Suite is now rapidly taking our base request, swapping out the normal input for our malicious payloads, and just flooding the server. So what happens next? How does the application's backend logic handle this absolute barrage of automated, injected data? Let's find out.
And this brilliantly illustrates what happens when the dust settles. A new window pops up, the attack results table. Every single request sent by the intruder is logged right here, row by row. It shows the payload used, the status code returned, and the length of the response. I want to draw your attention specifically to row number 1, where our payload was simply the word admin.
Notice the critical logic happening in the status column. When an authentication attempt fails on this application, the server typically returns a standard 200 OK status code, which just reloads the login page with a basic error message. But for our admin payload, the status code returned is a 302. In HTTP terminology, a 302 is a redirect. And in the context of a login page, a sudden redirect is a massive anomaly. It's a huge indicator that the application actually accepted our input as valid and is successfully redirecting us to the authenticated user dashboard. We bypass the lock.
We highly suspect we have access, but we need visual proof, right? Still within the attack results window, we click on the specific request that generated that 302 redirect. In the bottom pane, we select the Response tab, and then we click the Render subtab. This is an incredible feature because it actually processes the HTML response and shows us exactly what a web browser would display if it received this traffic.
So the crucial point is, looking at the rendered page, our smoking gun is sitting right there at the top. We see the application header proudly displaying, logged in admin, admin. This text proves, beyond a shadow of a doubt, that we successfully compromised the application. We completely bypassed the intended security protocols and gained full admin access entirely through automated proxy manipulation and targeted fuzzing. How cool is that?
We've literally gone from a simple intercepted request to full administrative compromise in a matter of minutes. It's an incredibly potent demonstration of exactly why security professionals rely on these techniques every single day. Which leaves us with this somewhat sobering thought. If a simple, automated fuzzer equipped with just a basic payload list can capture root access this quickly on a vulnerable system, how easily could hidden vulnerabilities be exposed in your own web applications right now? Keep questioning, keep learning, and as always, stay focused.